Phasor method. We have seen in the earlier section that the AC voltage and current are expressed as V is equal to Vm cos omega t and I is equal to Im cos omega t plus or minus delta. Here, both I and V are harmonic functions which are varying with time. We shall be discussing the method of adding such harmonic waves, which are immensely useful in electrical engineering. This method, called the Phasor method, let us consider a harmonic function. I is equal to Im cos omega t plus delta. In order to understand the Phasor method, a vector whose magnitude is equal to Im is drawn from the origin of a coordinate system. In our case, the phase of the cosine function at any instant t is given by omega t plus delta. So the given vector should be drawn in such a way that it makes an angle omega t plus delta with the x-axis. Two things have to be noted here. The phase omega t plus delta changes with time, or in other words, the angle between the vector shown in the figure and the x-axis and also the angle with respect to y-axis keeps on changing with time. The vector will rotate with angular frequency omega in the xy plane. Such a rotating vector is known as phasor. The x component of the vector at any instant t is equal to t will give us the value of Im cos omega t plus delta, which gives us the instantaneous value of the current. In order to calculate the summation of several functions like I1 cos omega t plus delta 1 plus I2 cos omega t plus delta 2 plus etc., one has to just take the algebraic summation of the x component of the respective phasors. The other advantage of the above method is that by taking the y component, that is cos pi by 2 minus omega t plus delta is equal to sin omega t plus delta, function is obtained. Hence, we can deal with the sine function by considering the y component of the vector. Let us consider an example of addition of the two harmonic functions. I1 is equal to I1m cos omega t plus delta 1 and I2 is equal to I2m cos omega t plus delta 2. In the first step, the vectors representing I1 and I2 are drawn and then their vector addition is calculated. The vector I represents a function which is the resultant of the two harmonic functions, which are represented by vectors I1 and I2. The amplitude of the resultant harmonic function is equal to the length or value of OP. Its phase angle is equal to phi. It has to be remembered that the magnitude of the vectors I1, I2 and I are given by I1m, I2m and Im respectively. From the above figure, we can see that delta 2 minus delta 1 is the angle between I1 and I2. Now, Im squared is equal to I1m squared plus I2m squared plus 2I1m I2m cos delta 2 minus delta 1. Let delta be equal to delta 2 minus delta 1 equal to be the phase difference of the functions I2 and I1. Therefore, Im squared equal to I1m squared plus I2m squared plus 2I1m I2m cos delta.